Dear students, welcome back to ALPHORES e-learning classes. Okay, today definition of radical axis. Radical axis, it is a straight line. Okay, here the locus of a point which moves such that its powers with respect to two circles are equal is a line called radical axis. The locus of a point which moves such that its powers means power of a point P, its powers with respect to the two circles are equal is a line called radical axis. Suppose here we have two circles S equal to 0 and S dash equal to 0. S equal to 0 and S dash equal to 0. This is the radical axis. This is the radical axis. This line is called radical axis. Here, from any point on the radical axis, powers with respect to the two circles S equal to 0 and S dash equal to 0 are equal. Here, this is the radical axis. From any point on the radical axis to the two circles, powers equal. Powers equals means what? S11 value equal. S1 here, suppose the point P. Here P lies on the radical axis. The point P lies on the radical axis. From the point P, with respect to the two circles, powers equal. The power of a point P with respect to the two circles equal. Okay, right here, suppose here S means x square plus y square plus 2gx plus 2fy plus c equal to 0. S dash x square plus y square plus 2g dash x plus 2f dash y plus 3 dash equal to 0. Here let P equal to some x1 comma y1. Let P equal to x1 comma y1 is any point on the radical axis. Let P x1 comma y1 be any point on the radical axis. Now from the point P, the power of a point P with respect to these two circles equal according to the definition. According to the definition, the power of a point, the locus of a point which moves such that its powers with respect to the given circles are equal. It means the power of the point P with respect to S equal to 0 and the power of the point P with respect to S dash equal to 0 are equal. It means S11 equal to S11 dash. S11 means the power of the point P with respect to a circle S equal to 0. S11 dash means the power of the point P with respect to the circle S dash equal to 0. Now these two are equal according to the definition. Okay, now S11 equal to S11 dash. S11 means x1 square plus y1 square plus 2gx1 2fy1 plus c. It is S11. Next S11 dash x1 square y1 square plus 2g dash x1 plus 2f dash y1 plus c dash equal to 0. Okay, now these two are cancel, left side, right side. Taking left side, then it is 2 of g minus g dash into x1, 2 of 2g x1, right side 2g dash x1. Here when taking left side, here 2 of x1, 2x1 common, remaining g minus g dash. 2 of similarly y term 2 of f minus f dash into y1 plus c minus c dash equal to 0 when taking left side. Okay, now locus of P. Locus of P is 2 of g minus g dash into x, 2 of f minus f dash into y plus c minus c dash equal to 0. This is the radical axis. A locus of P is 2 of g minus g dash into x plus 2 of f minus f dash into y plus c minus c dash equal to 0. A locus of P. Actually, this is what s minus s dash. This is what radical axis of these two circles. This line is called radical axis of these two circles. Here, actually, this is right as locus of P. The locus of P is locus of P. This is equal to right as s minus s dash equal to 0. Here this s minus s dash, x square cancel, y square cancel. Next 2gx minus 2g dash x. It is 2 of g minus g dash into x plus 2fy minus 2f dash y, 2 of f minus f dash into y plus c minus c dash equal to 0. A locus of P is, this is the line. Here now this is called radical axis of these two circles. This equation is also right as s minus s dash equal to 0. Therefore, the radical axis of two circles s equal to 0 and s dash equal to 0 is s minus s dash equal to 0. Okay. Radical axis of two circles s equal to 0 and s dash equal to 0 is s minus s dash equal to 0. Here, this diagram, this is s equal to 0, this is s dash equal to 0. The radical axis of these two circles is, this is the straight line. Equation of this line is s minus s dash equal to 0. Here s minus s dash means what? 2 of, suppose s equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. And s dash equal to x square plus y square plus 2g dash x plus 2f dash y plus c dash equal to 0. S minus s dash. Now equation of radical axis. Equation of radical axis is 2 of g minus g dash into x plus 2 of f minus f dash into y plus c minus c dash equal to 0. A radical axis of these two circles. This is the radical axis of these two circles. Equation of this line is 2 of g minus g dash into x plus 2 of f minus f dash into y plus c minus c dash equal to 0. Now here radical axis of here, from any point on the radical axis, to these two circles, powers equal. Powers equals means what? S11 equal to S11 dash. Squaring, applying square root on both sides. It is what? Length of the tangent. Length of the tangent from any point on the radical axis to the two circles also equal. If the powers equal, power of a point P, here where P is a point on the radical axis, when the powers are equal with respect to the point on the radical axis, then length of the tangent also equal. Here the length of the tangents from any point on the radical axis to these two circles is equal. Length of the tangents from any point on the radical axis to these two circles is equal. Okay, right. Next, also this is the radical axis of these two circles, and radical axis of the two circles is perpendicular to the line joining the centers. Here radical axis of the two circles is perpendicular to line joining the centers. Here center of the circle is what? Center of the circle is C1. For suppose C1 equal to what here? Minus G comma minus F. Next C2. center of this circle, minus G dash comma minus F dash. Here this line, this is what radical axis of these two circles. This line joining the centers are two perpendicular. A slope of C line joining C1 C2. Slope of C1 C2 equal to what? Slope of the line joining C1 comma C2 is what? Y2 minus Y1 by X2 minus X1. It means F minus F dash by G minus J dash. G minus J dash. Okay, it is slope of C1 Y2 minus Y1 by minus F dash plus F by X2 minus X1 minus G dash minus into minus plus G. Okay, slope of C1 C2. This is slope of radical axis. Slope of radical axis equal to RA means radical axis. Slope of radical axis. This is the radical axis. Slope of this line, it is in the form AX plus BY plus C equal to 0. Slope of this line is what? Minus of G minus G dash by minus A by B. F minus F dash. Observe these two. When multiplying these two, we get minus 1. G minus G dash cancel. F minus F dash cancel. Therefore, here plus 1 into minus 1, it is minus 1. Therefore, product of the slopes of these two lines is minus 1. It means these two are perpendicular. C1, C2 and radical axis of the two circles are perpendicular. In this diagram, here this is the radical axis. This is the line joining the centers. Here the radical axis of the two circles is perpendicular to the line joining the centers of given circles. Okay, next. Okay, some important points, note point. First one, if C1, C2 greater than R1 plus R2. If C1, C2 greater than R1 plus R2, in this case, relative position of two circles is like this. One circle completely lies outside of the other circle. In this case, radical axis. If one circle completely lies outside of other circle, the radical axis of the two circles is lies in between the two circles. And this is the radical axis, and this radical axis is perpendicular to the line joining the centers. Here, if C1, C2 greater than R1 plus R2, one circle completely lies outside of other circle. In this case, radical axis of two circles lies in between the two circles. Next, second one. C1, C2 equal to R1 plus R2. C1, C2 equal to R1 plus R2. In this case, C1, C2 equal to R1 plus R2 means relative position of two circles is what? Two circles touch externally. Two circles said to be touch each other externally. If C1, C2 equal to R1 plus R2, the two circles touch each other externally. In this case, common tangent at the point of contact. This point is what? If these two circles touching at this point, then this point is called the point of contact of these two circles. Now this is what? Common tangent at the point of contact. This line is called the radical axis of the two circles. If the two circles touch each other externally, then the common tangent at their point of contact is the radical axis. Observe here, this is also common tangent. This is also common tangent. Here, in the first case, here, here, The two circles touch externally. Actually, if the two circles touch externally, we have three common tangents. Three common tangents. Two direct, one transverse. Here only transverse common tangent is the radical axis of the two circles. Here these two common tangents are not radical axis of these two circles. Here if the two circles touch each other externally, we have three common tangents. Two direct, one transverse. Here only transverse common tangent is the radical axis of these two circles. Here if C1 C2 equal to R1 plus R2, then the two circles touch each other externally. In this case, common tangent at their point of contact is the radical axis of two circles. Next, modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. In this case, circle's position. Two circles intersect each other. Two circles intersect each other. Intersect at 2 points. These two are what? Point of intersection of the circles. Here in this case, common chord is exist. This case, common chord is, this is what? Common chord of these two circles. If modulus of R1 minus R2 less than C1 C2 less than R1 plus R2, two circles intersect each other. In this case, common chord of the two circles is the radical axis of the given circle, these two circles. Here this is the common chord. In this case, common chord is the radical axis of these two circles. Next, we have 5 conditions total. Fourth one, C1 C2 equal to modulus of R1 minus R2. In this case, two circles touching internally. In this case, only one common tangent is exist. Here, if C1 C2 equal to modulus of R1 minus R2, two circles touch each other internally. Here, C1 C2 equal to R1 plus R2, two circles touching externally. If C1 C2 equal to modulus of R1 minus R2, two circles touch each other internally. Now this is what? Point of contact. Okay, these two circles are touching at this point. This point is called the point of contact of these two circles. Now the common tangent at the point of contact is radical axis of these two circles. The two circles touch internally, then the common tangent at their point of contact is called the radical axis of the given circles. Here in this case, this tangent is what? Direct, this common tangent is what? Direct common tangent of these two circles. Observe these two, second and fourth one. If the two circles touch each other, here touch each other cases second and fourth. The two circles touch each other, then the common tangent at their point of contact is radical axis of the circles. The two circles touch each other, then the common tangent at their point of contact is radical axis of the given circles. Here, if two circles touch each other externally, the transverse common tangent is the radical axis. If the two circles touch each other internally, the direct common tangent is the radical axis of the given circles. Okay, now fifth one. Last condition, C1 C2 less than modulus of R1 minus R2. C1 C2 less than modulus of R1 minus R2. In this case, one circle completely lies inside the other circle. In this case, one circle completely lies inside the other circle, then the radical axis lies outside of both the circles. This is the radical axis. This is the radial axis. The two circles, C1, C2 less than modulus of R1 minus R2. Then one circle completely lies inside the other circle. In this case, radial axis of the two circles lies outside of both the circles. This is the radial axis. Here, once again, if C1, C2 greater than R1 plus R2, one circle completely lies outside of other circle. Then the radial axis lies in between the two circles. The two circles C1, C2 equal to R1 plus R2. In this case, two circles touch each other externally. In this case, transverse common tangent is the radial axis. Here, modulus of R1 minus R2 less than C1, C2 less than R1 plus R2. In this case, the two circles intersect each other. The common chord of the two circles is the radial axis of the two circles. If C1, C2 equal to modulus of R1 minus R2, two circles touching internally, then the direct common tangent is the radial axis of two circles. If C1, C2 less than modulus of R1 minus R2, one circle completely lies inside the other, then the radial axis lies outside of both the circles. Okay, now here another, for concentric circles, if the two circles are concentric, radial axis does not exist. Radial axis does not exist for the concentric circles. It is another point. Radial axis does not exist for concentric circles. Here another point. Radial axis of two circles. This is the radial axis of the two circles. This is the radial axis of the two circles. And the radial axis of the two circles bisects all the common tangents of given circles. Bisects all common tangents of given circles. This is the radial axis. Here, this line bisects all the common tangents. Bisects. Okay, here the radial axis of the two circles bisects all the common tangent of the given circles. Next, second one. The number of radial axes. The number of radial axes of n circles. The number of radial axes of n circles is nC2. nC2. The number of radial axes of n circles is nC2. Here, the radial axis of two circles is what? Question. The number of radial axes of two circles, for suppose n equal to 2, is what? 2C2. 2C2 means what? 1. 2C2. Here NCN equal to 1. According to the formula, NCR equal to n factorial by n minus r factorial into r factorial. NCR equal to what? N factorial by n minus r factorial into r factorial. Here the number of radial axes of n circles is nC2. nC2. Suppose here the number of radial axes of two circles is 2C2. 2C2 means what? 1. The number of radial axes of three circles. The number of radial axes of three circles is 3C2. 3C2 means 3. 3C2 value 3. NC n minus 1 value n. NC n minus 1 value, here n factorial, NC n minus 1 means here n factorial by n minus, here R means n minus 1, n minus of n minus 1, it is 1 factorial into n minus 1 factorial, n factorial by n minus 1 factorial, n factorial it is n into n minus 1 factorial, n into n minus 1 factorial by n minus 1 factorial, get cancelled, remaining n. Here the number of radical axes of 3 circles is 3C2. It is 3C2 means what? 3. For suppose 3 circles given, 3 circles given, here radical axis 3 possible here. This is the radical axis of these 2 circles. This is the radical axis of these 2 circles. This is the radical axis of these 2 circles. Here the number of radical axes of 3 circles is 3C2. Given 3 circles, therefore 3 radical axes possible. Here the number of radical axes of 4 circles is 4C2. 4C2 value according to the formula. Okay. Another point, the locus of the center of a circle, the locus of the center of a circle which occurs given 2 circles, the locus of the center of a circle which occurs given 2 circles orthogonally is the radical axis. Radical axis of given circles. Here the locus of the center of a circle which occurs given 2 circles orthogonally is the radical axis of given circles. These 2 are given circles. The locus of the center of a circle. The locus of the center of a circle. The locus of the center of a circle which occurs given 2 circles orthogonally is the radical axis of given circles. Observe this diagram. This circle curves these 2 circles orthogonally. It means angle between these 2 is 90 degrees. Angle between these 2, 90 degrees. Here it means this circle curves these 2 circles orthogonally. In this case, center of the circle must be lies on the radical axis of these 2 circles. Here the locus of the center of a circle which curves given 2 circles orthogonally is the radical axis of these 2 circles, given circles. Here the circle curves these 2 circles orthogonally. In this case, the center of the circle must be lies on the radical axis of given circles.